Hello everyone. This is the 21st lecture of I-451 Engineering Economy. So today we are going to solve two more problems from the end of chapter 5. And then we are going to move on to the next chapter, chapter 6. Okay, here's the first problem that we are going to solve for today, which is problem number 5-81. So we are considering 5 mutually exclusive alternatives, A through E, like this. And the interest rate, the given interest rate is 10%. If all of the alternatives have a 10-year useful life and no service value, which alternative should be selected? Okay, so this is the situation of fixed input. Okay, so we are solving problem number 5-81. And this is a situation of fixed input. Okay, so the criterion that we are going to use is to maximize the present worth of benefit. So use criterion maximize present worth of benefits. Okay. And by inspection, you can see that alternative C is preferred over alternatives A and B because it has larger benefits, right? Here, uniform annual benefit for the last 5 years, the alternative C is $110. However, alternatives A and B is $50 and $100 respectively. So obviously, the alternative C is preferred over alternatives A and B. Okay. So here, alternative C is preferred over alternatives A and B, right? Likewise, alternative E is preferred over alternative D because it has larger uniform benefits, right? Likewise, alternative E is preferred over alternative D. So our problem reduces to choosing between alternatives C and alternative E. Is that correct? And alternative C has a uniform annual benefit of $100 for the first year and $110 for the next 5 years. So for alternative C, we want to obtain present worth of benefits. Which is $100 for the first 5 years. So P given A, 10% over 5 years. And then $110 for the next 5 years. So again, P given A, 10% over 5 years. And then this can be converted to an equivalent present sum. So you need to multiply by P given F 10% over 5 years. Okay? So we want to find these table values from our text. 10% P given A over 5 period is 3.791. So this is 3.791, right? This one and this one too. What about P given F? 0.6209. This is 0.6209. So how much is this? How much is the present worth of benefits for alternative C? This is the $638. Okay. So graphically, this is what we've done. We want to find the present worth of benefit. Then for the first 1, 2, 3, 4, 5 years. The uniform annual benefit is $100, right? 0, 1, 2, 3, 4, 5, then 6, 7, 8, 9, 10, 7, 8, 9, 10, and the uniform series of 110. Okay? So what it is here is we convert this uniform series to the equivalent present sum P at the end of period 0, and then the next 5 payments of $110 has been converted to the equivalent present sum. Okay, of course what it is here is first we convert this uniform series of $110 to this P prime at the end of period 5, and then convert this to the equivalent present sum P by multiplying this vector. Okay. How about alternative E. Then. The present worth of benefit. The same way, it's going to be 150 times P given A, 10% over 5 period, plus 50 times P given A, 10% over 5 period, and then P given F, 10% over 5 period. Okay? The same way. The cash flow diagram is like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So first 5 years, has a uniform annual benefits of $150, and then $50 for the next 5 years. Okay. So from here, we convert this to the equivalent present sum of money, P, at the end of period 0. And also you need to convert this uniform series to the present sum, let's say P prime, at the end of period 5 by doing this. And then again, convert this P prime to the present equivalent present sum of money, P, at the end of period 0. So you need to multiply this factor. Okay? And we already know this factor values 3.791, and this is 0.6209. Okay? And how much is that? So the present worth of benefit for alternative E is $686.40. Okay? So we need to choose between alternative C and E by comparing the present worth benefits of $638 for alternative C and $686.40 for alternative E. So obviously, since these numbers are a lot larger than this, we're going to choose alternative E, okay, to maximize your benefit. Okay, then next problem. Actually, this is the last problem from the end of chapter 5. Which is problem number 5-84. The management of an electronics manufacturing firm believes it is desirable to automate its production facility. The automated equipment would have a 10-year life with no salvage value at the end of 10 years. The plant engineering department has surveyed the plant and suggested there are 8 mutually exclusive alternatives, and summarized in this table like this. So there are 8 alternatives, which includes its initial cost in $1,000 and net annual benefits in $1,000. If the firm expects a 10% rate of return, which plan, if any, should it adopt? So here, the present worth of benefit can be calculated by net annual benefit times what? So we are working on problem number 5-84. Here the present worth of benefit can be calculated by net annual benefit right here. Net annual benefit times P given A 10% over 10 years. Okay? So let's add one more column to this original table. Or let me reconstruct the table. 1, 2, 3, 4, 5, 6, 7, and 8. So we have 8 different plans. And the first column is about initial cost in $1,000. So 265, 220, 180, 100, 305, 130, 245, 165. Okay, and actually $1,000, right? The units are $1,000. So I'm going to put K. And the next column includes net annual benefit. And 51,000, 39,000, 26,000, 15,000, 57,000, 23,000, 47,000, and $33,000. So next column is about present worth of benefit. Okay. So in order to get this present worth benefit, we need to get this table value. Okay. P given A 10% over 10 periods is given as 6.145. This is the 6.145 from the compound interest table. Okay. So what you need is, for the plan 1, 51,000 times 6.145. And right here for plan B, 39,000 times 6.145. And 26,000 times 6.145 goes here. Okay. So let me use the spreadsheet software to get the present versus benefits for each of these 8 different plans. Okay. Okay, so here we have 313 $313,400. Then okay, so the next value is 239,700, 159,800, and 92,200, 350,300, and 141,300, 288,800, $202,800. Okay. And next, what you need to do is to compute net present worth. Net present worth can be computed by present worth of benefit, right, minus present worth of cost. Okay. So here we already got the values for present worth of benefit for each of these plans, and here present worth of cost is given already. So here net present worth for plan number 1 would be obtained by 313,400 minus 265,000. Okay. So that's going to be $48,400. Likewise, the net present worth for plan number 2 would be 239,700 minus 220,000. So it's going to be 19,700. So the same way, plan number 3, the net present worth would be negative value. It's going to be 20,200, but negative. Okay. And the next one, net present worth for plan number 4, is also negative value, negative $7,800. How about this? 45,300 and here 11,300 and 43,800 and $37,800. Is that right? Okay. So in order to maximize the net present worth, you need to choose plan number 1. Okay? Because that provides the highest number. Okay, so now let's talk about chapter 6 of our text. Which is about annual cash flow analysis. Okay? In chapter 6, we will apply annual cash flow techniques in various situations in selecting the best alternatives. Okay? And I mentioned this earlier. There are 4 major methods: cash flow analysis of resolving alternatives into comparable values, the present worth analysis in chapter 4 is one of them. And in this chapter 6, we will talk about annual cash flow analysis. Later in chapter 7, we will learn about rate of return analysis, and also future worth analysis. Can be found in chapter 9. Okay? Of course, when correctly applied, all of these evaluation methods leads to the same result. Okay? However, the annual cash flow method is often the best approach, because saying that a project will cost you $100 per week, or a project will save you $10,000 per year makes intuitive sense, even to people who have never heard of engineering economic analysis. And the EUAC, that is the abbreviation of the equivalent uniform annual cost. So here, EUAC, which is the uniform So EUAC, the equivalent uniform annual cost. is the uniform dollar amount, uniform dollar amount at the end of periods. 1 through n, that is equivalent to the project cost. Okay. Given with an initial cash amount P. That is the initial cash amount P, and S. S is the service value. At the end of period, interest period P. At the end of interest period P. I'm sorry, at the end of interest period N, right? Okay. And the equivalent uniform annual cost may be computed in these three different ways. Of course, each of these three equations lead to the same values. Okay? This is the 6-1, 6-3, 6-4. I believe in our text what is that? Text page number 193. Okay. Okay. And the three criteria for economic efficiencies are summarized in this table in terms of annual cash flow analysis. So here, neither input nor output is fixed. Then you need to maximize the EUAW, which stands for equivalent uniform annual worth. And the equivalent uniform annual worth can be computed by equivalent uniform annual benefit minus equivalent uniform annual cost. Okay? If the case of fixed input, then we need to maximize equivalent uniform annual benefit. If the fixed output, then we need to minimize equivalent uniform annual cost. And this table is very similar to the one for the present worth analysis in chapter 5, right? Like this. So if you compare these two tables, then you can find the similarities. Okay? And also let you know that when we apply annual cash flow techniques, you may have 5 different analysis periods situation. Here's the case 1, 2, 3, and 4, 5. Okay? And we will see each of these cases one by one with end of chapter problems. Okay, now let's solve some of end of chapter 6 problems together. So the very first problem that we are going to solve is problem 6-1. So we are required to compute the equivalent uniform annual benefit for this cash flow based on a 10% interest rate. So if you look at the period by period change amount, how much is that? It is $15, positive $15. And back in chapter 5, right? Back in chapter 5, we have learned about arithmetic gradient series, where the cash flow has a constant or uniform amount of change each period. So this given cash flow can be broken into two components, one for the uniform annual series and another for an arithmetic gradient series, right? So now let's draw those two components. Okay, so we are dealing with problem number 6-1. Okay, let me redraw the cash flow diagram. Here's the given cash flow diagram. At the end of period 1, there is a positive cash flow of $15. At the end of period 2, $30. At the end of period 3, $45. At the end of period 4, we have $60. And we are going to use 10% interest rate. So the period by period change amount is positive 15, right? So this cash flow diagram can be broken into two one, two, three, 4, 0, 1, 2, 3, and 4. Okay. The first one is the uniform series of $15. Next one for an arithmetic gradient series of G equals 15. So at the end of period 2, we have 15, period 3, 30, period 4 is 45. Okay, like this. And we want to calculate the equivalent uniform annual benefit. Which is just like this. Okay. So this A gives you the equivalent, uniform annual benefit. Okay. So how do you get this equivalent, uniform annual benefit? Here, equivalent uniform annual benefit would be $15, right? Plus arithmetic gradient of $15 times A given G, 10% over 4 periods. Okay. So if you compute this value, then it will give you the equivalent uniform annual benefit, which would be the answer for problem number 6-1. Okay. So let's get the table values for this vector. 10% A given G over 4 periods, that's going to be 1.381. Okay. So how much is that? It's going to be $35.72. Okay. Okay. Next problem is problem number 6-2. Compute the equivalent uniform annual benefit for these cash flows. So how do you compute equivalent uniform annual benefit? I would convert each of these to future money to a present worth, and then again convert the present sum P to a series of equivalent uniform end of period cash flows, which is equivalent uniform annual benefit. Okay. Problem 6-2. Zero, 1, 2, 3, 4, 5. So at the end of period 1, there is negative cash flow of $100. At the end of period 5, another $100. Okay. So what I'm going to do is convert each of these to future money to an equivalent present sum of P at the end of period 0. Once we get this present sum of money P then this present sum of money P can be converted to the equivalent uniform annual benefits. Okay? So that's what I'm going to do. So here the present worth of benefit would be 100 times P given F 15% over period 1 plus 100 P given F 15% over 5 periods. Okay? So P given F 15% over 1 period is 0.8696. This is 0.8696. Okay? What about this? Over 5 periods, 0.4972. 0.4972. Then how much is the present worth of benefit? Right here. This is the $136.68. Now we know that the present worth of benefit is $136.68. Now we want to convert this present sum of money to the equivalent uniform annual benefit, which is A down here. Okay? So it's going to be 136.68 times A given P. Same interest rate, 15% over 5 periods. Okay? So what is the value of this? A given P over 5 periods, that is 0.2983. 0.2983. Is that correct? A given P, 0.2983. Okay. So how much is the equivalent uniform annual benefit? Okay, this is $40.77. That is the answer, okay, for problem number 6-2. Okay, next let's solve problem 6-3. So compute the equivalent uniform annual benefit for these cash flows. So here, the period by period change amount is negative 15. So obviously this problem has a decline gradient. So just like problem 6-1, this given cash flow can be broken into two components. One for the uniform annual series, another for an arithmetic gradient series, right? So this is the problem 6-3. Let me redraw the cash flow diagram. Zero, 1, 2, 3, and 4. 60, 45, 30, and 15. Okay, and the given interest rate is 12%. Here you can see the change amount period by period change amount is negative $15. So we can use the concept of arithmetic gradient series here. Okay, and we want to know the equivalent uniform annual benefit. Okay. So first, this given cash flow can be broken down to these two components, 0, 1, 2, 3, and 4. 0, 1, 2, 3, and 4. The first one is the uniform series of $60. Then what is left over? You have negative cash flows, 15, 30, and 45. Okay? So here you can say G is negative 15. Okay? Now we want to calculate the equivalent uniform annual benefit. Which looks like this. E, U, A, B. Okay, we want to compute equivalent uniform annual benefit, which looks like this. So the equivalent uniform annual benefit would be 60 plus this, right? Actually, this is going to be negative 15, right? Because the arithmetic gradient is negative 15 times A given G, 12% over 4 periods. That's it. So what is the value of this? A given G over 4 periods, there's 1.359. This is 1.359. then how much is the equivalent uniform annual benefit? Okay, so this is going to be $39.62. Okay, that is the equivalent uniform annual benefit of this cash flow. Okay, then what about problem 6-4? If the interest rate is 6%, compute the equivalent uniform annual benefit over 60 years that is equivalent to the receipts shown in these cash flow diagrams. So we are working on problem number 6-4. So how would you compute equivalent uniform annual benefit over 6 years here? I think this problem is very similar to this problem looks very similar to problem 6-2, right? So in problem 6-2, what I've done is convert these two future sum of money to the present, to the equivalent present sum of money, and then convert it again to the equivalent uniform annual benefits over 5 periods. So what I'm going to do here in problem number 6-4 is to convert each of these two single payments to either the present sum of money or future worth of money at the end of period 6 years, and then convert those values to a series of equivalent uniform annual benefit over 6 periods. Okay. So let me redraw the cash flow diagram. Zero, 1, 2, 3, 4, 5, and 6. At the end of period 2, there is $200. At the end of period 4, $100. And we are going to use 6% of interest rate. Okay. So I'm going to convert each of these two payments to, this time, to the future worth at the end of period 6. Okay. And then once we get this future sum of money at the end of period 6, again, this future sum of money will be converted to a series of equivalent uniform annual benefit. So here we have equivalent uniform annual benefit. Okay? So that's what I'm going to do. So here, how would you get future sum of money? F equals 200 times F given P, 6% over 1, 2, 3, 4 periods, plus 100 times F given P, 6% over 2 periods, right? So F given P 6%, over 4 periods is 1.262. So this is the 1.262. Over 2 periods is 1.124. 1.124. Okay. Then how much is this future sum of money F at the end of period 6? This is going to be $364.80. So now we know this future sum of money at the end of period 6, which is $364.80. So we're going to convert this future sum to the equivalent uniform annual benefits over 6 periods. Okay. So here EUAB is equal to $364.80 times A given F, 6% over 6 periods. Okay. So what is this value? A given F over 6 periods is 0.1434. 0.1434. So how much is that? This is $52.32. Okay, that is the equivalent uniform annual benefit of these receipts shown in this diagram. And alternatively, you may convert each of these 2 single payments to the present worth, and then convert the present worth, present sum p-value to the series of to the equivalent uniform series of annual benefits. Okay. So alternative way. So we have 0, 1, 2, 3, 4, 5, and 6. And at the end of period 2, there is 200. At the end of period 4, is 100. We are using 6% of interest rate. So I want to convert these two single payments to the present worth P. Okay. Once we get this present sum of money, then we can convert it to the equivalent uniform annual benefit. Okay. So how'd you get this present sum of money P? That's going to be 200 P given F, 6% over 2 periods, plus 100 times P given F, 6% over 4 periods. Okay. So P given F over 2 periods is 0.8900. Over 4 periods is 0.7921. 0.7921. Okay. So how much is that? This is $257.21. Okay. Now we know that this present sum of money is $257.21. So this present sum of money can be converted to the equivalent uniform annual benefit over 6 periods. Here EUAB is equal to $257.21 times A given P, 6% over 6 periods. Okay. So what is this table value? A given P over 6 periods is 0.2034. This is 0.2034. Okay. Then how much is this? This is $52 and 32 cents. Okay. Okay. So I'm gonna stop here for today. And then next time we are going to continue solving the end of chapter 6 problems. Okay? Okay, thank you. I will see you next time. Bye-bye.